Hello everyone, I am Shubham Garg and welcome back to the lecture series of DSCH Software. So in the previous lecture we have seen how to make a half adder and a full adder using the circuits which we have developed before, and we have used the symbols and we have used the half adder symbol to develop this full adder. Alright, so similarly now in this video we are going to see how to make a half adder and half subtractor and full subtractor circuits using the circuits which we have developed previously. So first of all, let me show you the truth table and circuit diagram of half subtractor. So here this is the circuit diagram of half subtractor. It is almost the same as half adder, just there is one difference, that is while connecting this A to this AND gate, there is an inverter in front of the A input. All right. This XOR gate is same as before. Okay, so we will use three symbols in making the half subtractor. That is the symbol for XOR gate, symbol for inverter, and symbol for AND gate. Okay, so let us start making the half subtractor. Let's go to File, create a new file, and now we will be adding the symbols. So for symbols, I need XOR, okay, inverter, and AND gate. I need these three symbols. So this is our XOR gate. Again, next insert the AND gate. So this is our AND gate, and now we need the inverter. All right, so here is our inverter. Okay, so these are our symbols which we need for the half subtractor circuit, and now we will have our input, that is A, B and borrow. Okay, so we need the output, that is difference and borrow, A, B, difference and borrow. So the inputs are A and B, these are here, and for the output this one is for difference and this one is for borrow. So let us join the wires to complete the circuit. So now first is the XOR gate. This thing is same as in the case of half adder. Both the inputs are connected towards the XOR gate. You can see A and B both are connected to XOR gate. Then B is normally connected to AND gate, but while connecting A, there is an inverter in between. Okay, so now first of all, here is our inverter, and this input should be connected to A. Now next, B is connected as it is towards the input B. Okay, so now let's change the pin names as well. Yeah, so we will name it as A, and this will be our B. This is difference and we'll denote it using D, and this is borrow. Okay, so we will denote it using BO or B0. It's up to you. Okay, so I will denote it using BO. You can write full name as well. It's up to you. So this is the circuit of half subtractor. Let's run it and see if it is working properly or not. Okay, so now here is the truth table for half subtractor. So you can see when both the inputs A and B are 0, difference and borrow should be 0. Okay, so let's just run the simulation. You can see both the inputs are 0, difference and borrow are 0. Okay, when A is 0 and B is 1, that is A is 0 and B is 1, difference is 1 and borrow is again 1. Similarly, when A is 1, B is 0, difference should be 1 and B should be 0. So when A is 1, B is 0, difference is 1 and borrow is 0. And finally, when A and B both are 1, difference and borrow both are 0. So this is how we develop a half subtractor. Okay, and we can see it is working fine. So let us save our schematic. Okay, let's save as half subtractor. And now what we will do is we will create a symbol for this. So just go to file, schema to new symbol. Okay, I need difference above, so I will just change the order. Yeah, A, B, difference and borrow. So it is half subtractor CMOS symbol. Okay, so now you can see here this was the half subtractor. Now let's go towards the full subtractor. Okay, so here this is the circuit diagram of full subtractor. All right, again what we can do is either we can extend this half subtractor, sorry, this is the half adder, yeah, either we can extend this half subtractor or we can join two half subtractors to make a full subtractor. All right, so we are going to extend two half subtractors to make a full subtractor. All right, so let us, so first of all let us have the symbols for two half subtractors and one OR gate. Okay, like we did in the case of full adder. Okay, so we will create a new file and we are going to insert the symbols. So from here we are going to insert this half adder, that is the half adder 1, and now we are going to insert another half adder. So this is the half adder 2. Okay, and now we need to insert the symbol that is for OR gate. So this is the symbol, there is the symbol for OR gate. Okay, I am going to keep it here. Yeah, so this is our half subtractors and this is our OR gate. Okay, so now for the full subtractor there are basically 3 inputs and 2 outputs, that is A, B and borrow in. All right, and difference and borrow out are the outputs. So first of all our first input is the input A and B. So here is our input, that is A, and here is the other input B. Okay, so let us connect A and B. So these are our inputs. Let's change the name as well. This is for A, this is for B. Okay, and now this difference should be connected to the input of the other half subtractor the same way we did in the half adder, in full adder when we made from half adder. Okay, next input is the borrow in. All right, so if you remember in the full adder there was carry in input, so now here it is borrow in. Okay, so we will name it B in. Okay, so this is our third input. Now from difference here, this is the final difference output. So we are going to use LED for the output. Now this one is for difference. So we will just name it D. Okay, and now for the borrow output, what we need is we need both the borrows to go through the OR gate. Okay, that is both the borrows will pass through OR gate so that we can get the final borrow output. So now I will connect this borrow to A and I will connect the other borrow to B. So now it is connected to borrow A and borrow B, and this is our final output, that is borrow out. Okay, so we will denote it using B out or BO, it's up to you. Okay, so I will denote it using BO. Okay, it can confuse from here, so let's just change the name to B out. Okay, so this is our full subtractor which we have developed using two half subtractors. Same way we have developed the full adder. So now let us verify if our schematic is correct or not. So we will again go case by case and will verify every case using this truth table. So let's run the simulation, and you can see when A, B and borrow in are 0, difference and borrow out are 0. Okay, when A and B are 0 and borrow in is 1, difference and borrow are 1. Okay, yeah, you can see difference and borrow are 1. When A is 0, B is 1 and borrow in is 0, that is B in 1 and borrow in is 0, difference and borrow out are again 1. When B and borrow in both are 1, difference is 0, borrow out is 1. So that is when B and B in both are 1, B out is 1, difference is 0. When A is 1 and B in are 0, difference is 1, borrow is 0. So that is A is 1, you can see difference is 1 and borrow out is 0. Similarly, when A is 1, B is 0 and B in is 1, both D and B out are 0. When A and B are 1, again both of them are 0. Okay. So when all three of them are 1, difference and borrow both are 1. So you can see this verifies our schematic, that is the full subtractor. So let us save our schematic. Okay, by the way, you should make it a habit to save it before simulation. Okay, because in some case, by any chance or something, your schematic could get deleted, or some component get misplaced or something. So for that, it is better to always save before. So this is our full subtractor. Okay, so now we have saved the schematic, and we have completed full subtractor and half subtractor using the previous components. And similarly, in this way, we are going to use other logic gates, other components. We are going to use other smaller elements to make larger elements. Then we will create symbols from those larger elements, and we will use those symbols to create a further larger circuit. Okay, so that's how we are going to work using this DSCH software. So this is all for this video, guys. See you in the next video.